Hello viewers, in today's class we are going to solve yet another important problem from areas of bounded regions. So here we are considering the application of integrals in finding out the areas bounded by the different curves, right? So here we have the problem: find the area of the region bounded by this curve, which is denoted by C1, and the y-axis, right? And y-axis can be taken as the second curve, right? So we have here two curves. C1 is y square is equal to 2y minus x, and y-axis is the curve number 2, right? And here we'll see that this curve represents a parabola which opens on the left, right? And this is the y-axis, right? So let us start. So here first of all, let us take the curve C1 and let us convert this equation in the standard form of the parabola, that is y square is equal to 4ax, right? So here we have y square, and we can take this 2y to this side, so we have y square minus 2y is equal to minus x. Let us make the perfect square here. So we have y square minus 2y, and adding 1 here and adding 1 here, right? Now this becomes y minus 1 whole square, and this becomes taking a negative sign outside here, so we have x minus 1, right? Now if we take this y minus 1 as capital Y and capital X as x minus 1, then we see that we have y square is equal to minus x, and this equation is of this form, except we have a negative sign over here, which shows that the parabola, it opens towards the left side, right? So the shape of the parabola is like this due to this negative sign, because if we have here y square equal to minus 4ax, then the parabola, it opens on the left side, right? So now viewers, let us now once we have converted this equation into the standard form of the parabola, let us plot this parabola on the coordinate plane, right? For this we have to find the vertex of the parabola, which can be obtained by putting y is equal to 0 and x is equal to 0, right? So this gives us y minus 1 is equal to 0, and this gives us x minus 1 is equal to 0. So we have y is equal to 1 and x is equal to 1. So 1 comma 1 is the vertex of this parabola, right? So here we are drawing a rough diagram. So here we can take 1 and here we can take 1, so 1 comma lies somewhere here, right? So let us call this point as V, right? So here we are trying to plot this curve C1, right? Okay, now see, we have concluded that this parabola, it opens on the left. So let us find out the points at which this parabola intersect y-axis, right? So when this parabola intersect y-axis, then we must have x is equal to 0, right? So therefore putting x is equal to 0 here, we have y square is equal to 2y minus 0. So we have y square is equal to 2y, and we have y square minus 2y is equal to 0, and we have this equation, so we have y is equal to 0 and 2, right? So this parabola, it intersect y-axis at the point 0 comma 0, because we have x is equal to 0 and x equal to 0 comma y is equal to 2, right? So we have these two points. So 0 comma 0 is the origin itself, and 0 comma 2 it lies somewhere here. So this is 2, so here we have 0 comma 2, right? So now viewers, we have the 3 points on this parabola. So now we can join them. So we have the parabola like this, right? So this is the rough diagram of the parabola, which is given by y square is equal to 2y minus x, right? Okay, and the second curve, which is C2, and this curve is the y-axis, right? And the equation of y-axis is given by x is equal to 0. So this is y-axis, and the equation is given by x is equal to 0. Now we have to find the area of the region bounded by C1 and C2. So we have simply this region whose area is to be calculated. Now to obtain the area of this shaded region, what we have to do, we have to draw a vertical, here we have the horizontal strip. So here we have this strip, right? And this strip is the horizontal strip. It looks like this, and here we have, say this is point P, this is point Q, this is point R, and this is point S, right? So we have P, Q, R, S, right? So we have this horizontal strip, and to find out the area of this shaded region, what we do, we divide this region into such rectangular horizontal strips, right? And we have to find the area of one strip, and then we integrate it from 0 to 2, right? And we know that when we have a horizontal strip, that is the bounded region is divided into horizontal strips, then the area is given by A to B, and we have here x dy, right? And the limits are from y is equal to A to y is equal to B, right? So here we have A is 0 because the limits varies from 0 to 2. So here we have y is equal to 0, and here we have y is equal to 2. And for x, see the horizontal strip, it runs from y-axis to the upper end, or on the surface of the parabola, right? So the horizontal strip has its lower end at the y-axis and the upper end on the parabola, right? So x is calculated from the equation of parabola, right? So now from the equation of the parabola, we have the value of x as 2y minus y square, right? So here for this x, we'll substitute 2y minus y square, and here we have dy, right? And now we have a very simple integration, and the integral of y is y square over 2, and the integral of y square is y cube over 3, right? And the limits are from 0 to 2. Here 2 and 2 get cancelled. We have y square minus y cube over 3, and limits are from 0 to 2. Now we'll substitute y is equal to 2. So we have 2 square minus 2 cube over 3, and if we take y is equal to 0 here, so we have 0 square minus 0 cube over 3, and this is 2 square is 4, this is 8 over 3, and here we have 0, and this is 12 minus 8 over 3, that is 4 over 3 square units, right? So viewers, the area of this shaded portion which is bounded by this parabola and y-axis is given by 4 by 3 square units.